Subscribe to Tech Talks and hit the bell icon to get notifications about coolest and latest engineering technology in the first place. Next we will see that how we will generate the switching functions. So let us consider one switching function for sector 1. So here Tz is the total time of switching. So it is divided into two parts. One is 1, one is 2, 0 to T1. Other one is till T2, that is T1 to T2, T1 plus T2, and the remaining time that is not included over here, it will be considered as 0. So you can see in this equation that Tz equal to T1 plus T2 plus T0. Okay. So we have written this equation. How this equation comes? This equation comes from this part. You see that till T1 voltage vector V1 will be operated. For T2 voltage vector T2 will be operated. Voltage vector V2 will be operated, and the resultant will be V reference. So same thing is written over here, that from 0 to T1 voltage vector 1 will be operated. From T1 to T1 plus T2 voltage vector V2 will be operated, and the remaining time will be operated by null vector V0 or V7. So this one you can write it in by this line, that Tz into V reference is equal to V1 into T1 into V1 plus T2 into V2. Now we have just put on formulas and we have got this result, that T1 is Tza sine of pi by 3 minus alpha. Alpha is the angle that we have found out earlier, and T2 is by this one, where A is the modulation index. How we will find out the modulation index? By here, V reference by 2 by 3 VDC. Tz is the sampling time, that is 1 by frequency. Okay. So this is for sector 1. Now similarly we will find the switching time duration for all other sectors. So switching time duration for any sector, you can see that the formula is like this, where you see n over here. This n is the sector number. When n is 1, it is sector 1. When n is 2, it is sector 2, and likewise. And this alpha, this varies from 0 to 60 degree. Okay. So after determining this formula, okay, we will be getting that switching time duration for every sector over here. This is for upper 3 switches, switch 1, 3, 5, and this is for lower 3 switches, that is switch 4, 6 and 2. Okay. You can have a look in this chart that how this is prepared from using this previous formula. Okay. This you can observe a pattern over here, that is V0, V1, V2, V7, V7, V2, V1, V0. So from here it is the mirrored image of this part. Okay. And you see for sector 1 it is V1, V2. For sector 2 it is V3, V2. For sector 3 it is V3, V4. For sector 4 it is V5, V4. How we are getting this one? If we consider arbitrarily, suppose let us consider sector 4. So which two voltage vectors are mainly switching? V5 and V4. So let us go to the figure. You see sector 4, you see V5, V5 and V4, they are switching. So in whichever sector you are there, the adjacent two voltage vectors will be switching. Okay. Now we will be doing the MATLAB. In MATLAB we have already make this one. I have done this one just to save time. I will explain one by one, so don't skip the video because you may miss some important information. So let us go to this formula. So this we will be generating switching time duration for any sector. So for switching time duration, you see in all the T1, T2, we have this one in common. The first part are in common, root 3 Tz V reference VDC, root 3 Tz V reference by VDC. So you see, so this is V reference. V reference is what? 2 by 3 into VDC into MA. That is modulation index. I have taken modulation index of 0.9. Okay. Then VDC is 400. Then TZ. Our it is 50 Hertz. I have taken TZ as 1 cycle. That is 20 milliseconds. Okay. Then this one is nothing but this part, √3 TZ V reference VDC. You can obviously see that is square root of 3 into TZ. V3 is TZ into V1, that is V reference by VDC. Okay. Now we require what? We require angle and we require sector. Okay. We require angle and we require sector. Now you see for T1 we have written this part. Now we need to write this part. Okay. So what is written over here? It is sine n pi by 3 cos alpha minus cos n pi by 3 sin alpha. Okay. So you see that what I have written over here, I have written the first one that will be multiplied. Okay. Sine of U3, that is sine of this sector, into pi by 3, that is sine n into pi by 3, where it has gone, sine n pi by 3 minus angle minus alpha. So you can easily see this one, that you can write it as sine n pi by 3 minus alpha if you reduce this formula more. So I have taken the reduced formula. I have used this formula. Here bracket will be here, sine n pi by 3 minus alpha, the bracket will be here after this sign. I have used this formula. Likewise for T2 also I have used this formula. Okay. And U1 will be multiplied and then sine this one minus 1 pi by 3 plus U2. Let us check. You see this one, sine alpha minus n minus 1 pi by 3 minus alpha. So I have taken minus out. Okay. Now what I got T1 and I got T2. I got T1 and I got T2. Now T0 is what? T0 is TZ minus T1 minus T2. Okay. So T0, I will have to find out what is T0. So T0 is what? TZ. So this one is TZ. This one is minus T1 minus T2. Okay. Right. Now I will be finding out this one, this part. I will be making some functions over here that will be used by me later in this simulation. That is T1 plus T2 plus T0 by 2, T2 plus T0 by 2, T0 by 2. So these functions, how we are getting this one, I will be explaining. I have already explained it over here, that you see here this functions is what? T1 plus T2, T0 by 2, T0 by 2. So this part of the function, half part of this function, then this one is what? This one is T2 plus T0 by 2, and let me make it bigger. So this half, the first half is what? T1 plus T2 plus T0 by 2. The second part is what? T2 plus T0 by 2, and the third part is what? T0 by 2. Now this set of timing has been repeated everywhere in this switching pattern. Everywhere it is mirrored and it is repeated. Now the lower switch is actually not of switch 1, switch 3 and switch 5. So if I get this part, we can easily get the other parts also. For this reason, I will now make this formula that, so this is T0, this is T1, this is T2 and this is T0. So T0 is half, so I have divided it with this one, 0.5, multiplied it with 0.5. So T1 plus T2 plus T0 by 2. So T1, where I will get T1, I will be getting T1 over here. And then T2 I will be getting over here. And then minus plus T0 by 2. Okay, plus T0 by 2. Okay, here it is what? T1 plus T0 by 2. So T1 where I will get this one T1 and this is T0 by 2. Here it is what? T2 plus T0 by 2. T2 plus T0 by 2. And this one is T0 by 2. So this one is T0 by 2. So we will be getting T0 by 2. Right? So we have completed this part. So we will move to the next part. Till now what we have done, we have formulated what time period we require. Now we will see how we will use this time period to get the switching functions of each switches. So from here you can see that we are having those time periods. This T1 plus T2 plus T0 by 2, T1 plus T0 by 2, T2 plus T0 by 2 and T0 by 2. So what we will take one multiport switch. You will get it in signal routing. In signal routing you will get a multiport switch. Okay, and here you do one base contiguous and the number of data ports will be 6. Okay, number of data ports will be 6. It will be governed by this sector that we have determined by this sector. And how I will be doing that, now I am showing you that you see over here switch 1, here it is T1 plus T2 plus T0 by 2. The same thing is repeated in switch 2 also. Okay, so switch 1, so this value will go to here and T2 will be connected over here. That is switch 1 and switch 2 are having this time period. Next you see that T3 is S3 is T2 plus T0 by 2. Switch 3 is T2 plus T0 by 2. So S3, that is switch 3, this is T2. So this one will be connected over here. Now switch 4 is having switch 4 and switch 5, they are having T0 by 2. T0 by 2, switch 4 and switch 5. So T0 by 2, it will be connected in 4 and also in 5. And switch 6 it is having T1 plus T0 by 2. So this will be connected to switch 6. Now this will contribute to form our first sine wave. Similarly, we will this main part, it will be governed by the sector. Okay, and so in the second part, that we will be doing what? We will be doing this one, these sector 3. Sector 3 is switch 1 is T0 by 2, and say switch 6 is T0 by 2. Okay, so switch 1 is T0 by 2 and switch 6 is T0 by 2. Then here switch 2 is T1 plus T0 by 2. So switch 2, this will be T1 plus T0 by 2, that is this one. Then switch 2, switch 3 is switch 3 and switch 4 are same, it is T1 plus T2 plus T0 by 2, switch 3 and switch 4. Switch 3 is T1 plus this one, and switch 4 is also same. Switch 5 is T2 plus T0 by 2, so switch 5 is T2 plus T0 by 2. Switch 5 is T2 plus T0 by 2. So this will be the second sine wave. Similarly, we will do the other one, that this one, that sector 5. Okay, so here S5 and S6 are same, that is the T1 plus T2 plus T0 by 2. So let us just match. S5 is T1 plus T2, that is this one, and 6, this is also same, 5 and 6 are same, 5 and 6 are same. 1 is T2, 4 and 2, 3, 2 and 3 are same, T0 by 2, T0 by 2. So let us take 2 and 3. So 1 and 4. So 1 is what? Was T2 and 4 is what? T1. So 1 is T2 by T2 plus T0 by 2, and 4 is T1 plus, so this one. So this forms our sine wave. So these are those sine waves which will be later compared with a triangle, so that what we, this other things are similar what we have done in sine PWM. Okay, so the link is given in the description box. If you don't know what is sine PWM, I have given the link in the description box. Okay, so we will move to the next part, that is assembling of what we have done till now, and then getting the final result and analysis. In this section we will assemble and then we will run the program. Okay, so this was the original program, that we are having an induction motor, an inverter, and the open loop SVPWM. Okay, so we have taken 3 sine wave. So let us check now. So this is the sine wave. So this will be alpha, and this will be the angle. Okay, so let us run and then let us check. Okay, it is compiling. I think till here it will do. Okay, so let us zoom. So this is the sine wave of magnitude 1. Okay, the second one is the value of alpha, that what we are getting, and the third one is the value of angle. As you can see that the value of angle goes from minus 3.14 to plus 3.14, that is 2 pi. You can check it over here that this is 3, this is 3.2, so this is nearly 3.14, and in the negative half also it is going to 3.14. So that is, it is going from minus pi to plus pi, that is 2 pi. Okay, then what happens? Then we have done from the angle this sector determination. So in sector determination, so if this one is the angle, then this sector would look like what? Let us check. I think this will do. Yes. So this is the angle. It is going from minus path 3.14 to plus 3.14, and you see that this is sector. You see the minimum value is plus 1. This is sector 1. This is sector 2. This is sector 3, 4, 5, and this is sector 6. Okay. So this is the reason that we are getting some step jumps, why we have multiplied it with 1, 2, 3, 4, and 5, 6. Okay, if we have multiplied this one with any other number, then we will get other type of waveform. Okay, so this is our sectors. Next, let us see. Now let us check that how the sine waves look like, and let us check what was our input sine wave. Our input sine wave was first one is our input sine wave, and second one is the generated sine wave. So this is our generated sine wave. We have done this one and then assembled. So let us see. I think this will do. Yes. So you see our sine wave was of magnitude plus 1 to minus 1, and we are getting sine wave of this quality. Okay, it is exactly matching with the literature. So the value is 20 millivolt. So our triangle will also be 20 millivolt, and you notice another thing, that it is unipolar. So our triangle will also be unipolar, right? So when we are getting sine wave over here, so our sine wave was unipolar. In here we have what we have done, we have just generated one triangle, a carrier wave. So if you want to know how this triangle is generated, you just refer to my earlier videos, link is given there. Okay, so this is the triangle, and this one is the sine wave, resultant sine wave. So let us check. I think this will do. Yes. We'll take 2 cycles. You see I have created the sine wave so that it matches with 0 to 20 millisecond. Okay, and here also it should be from 0 to 20 millisecond, right? I have taken this triangle of 5 kilohertz, so you also generate triangle of 5 kilohertz or 10 kilohertz or whatever you like. Okay, now this triangle will be compared with this one, and other things will follow as sine PWM. Okay, now let us check the current waveforms of the motor. I think this will do. Let us check. Yes, the current waveforms are sinusoidal in nature, and you see that the speed is going up at no load speed, and also the torque is fine. Okay, so this is our SVPWM. If you like the video, do subscribe the channel and don't forget to share with your friends. So meet you in the next video. Thank you. Comment below about how you like this video. Check out the links in the description box about more such videos. Do click the like button if you like the video. If you are new to this channel, subscribe Tech Talks and don't forget to hit the bell icon.